In this video, we're going to extend our sign rules of multiplication and division away from just integers to more rational numbers, so positive and negative decimals and fractions. This sign rule is still going to come into play, so it's important that we remember things that are the same signs, so like two positives or two negatives. Your sign of either your product or your quotient is going to be positive. Again, that was same signs lead to a positive answer. Whereas if you have one of each, like a positive and a negative, or a negative and a positive, different signs of one another, there your answers are going to be negative. So keep that in mind while you're watching this video. Let's start with a basic review of multiplying fractions. Multiplying fractions is actually easier than adding or subtracting because you don't have to get common denominators. When you multiply fractions, you're going to multiply straight across your numerators and straight across your denominators. You should always check if you can simplify, and I'm going to show you two ways to do that. The first is to simplify after you multiply across. So in this first problem, 2/3 times 3/10, I'm going to multiply across my numerators and denominators and get 6/30. After that, now I'm going to look to see if I can simplify, and in this case, I can divide both by 6 and get my answer of 1/5. What some people like to do to work with smaller numbers is to simplify beforehand. So looking at this example, remember it can only simplify if it's on the top and the bottom. So here I have 3's both in the top and bottom that could kind of cancel each other out. And then I could go even further if I wanted to and simplify the 2 and the 10. 2 can go into 10 5 times. So now as I multiply across, 1 times 1 gives me 1 for my numerator, and 1 times 5 gives me with 5, and you can see that my answer is already simplified by doing it beforehand. Either one works, and you use whichever one you feel more comfortable with. If you're taking notes while you go, these would be great to put in. These two quick examples of multiplying fractions, and if you notice, we have some positives and negatives, so those sign rules come into play. First, I see a negative 2/5 times a negative 2/3. Those are both negative, so in my head I'm thinking I'm going to have a positive answer, but I still work it out the same way. Nothing simplifies because I don't have anything on the top and the bottom that could cancel out or simplify down, so I'm going to multiply straight across. Negative 2 times a negative 2 gives me a positive 4, and 5 times 3 gives me 15. So I have 4/15. That can't be simplified, so that's my final answer. Again, it was positive because I had a negative times a negative. In the second example, I have 4 1/6 times a negative 3/4. A positive times a negative, so again, in the back of my head, I'm keeping in mind that it's going to be a negative answer. When you have mixed numbers like this, the first thing that you have to do is change that to an improper fraction before you keep going. So I'm going to change 4 1/6 into 25/6. And that is what I'm going to multiply by 3/4. I can simplify a little bit here before I continue. This 3 and this 6 can go into each other. The key thing here is I'm not losing this negative. I'm still remembering that that's a negative. So when I multiply across, I have 25 times negative 1, which would be negative 25, over 2 times 4, which would be 8. If you wish, you can change that back into a mixed number, and that would be negative 3 1/8. Remember, I will take either. Both are correct. Now, unfortunately, decimals are more complicated than adding and subtracting when you get into multiplying and dividing. The key thing with multiplying decimals is how many digits, 0 included, are behind the decimal point to start. If I look at this example, I have 7/100 times 8/100. I have 1, 2, 3, 4 digits behind that decimal place. When I go to multiply these, I can ignore the decimals and really just focus on those digits of 7 times 8 and multiply them as if the decimals aren't there. That gives me 56, and then this is where those 4 digits comes back into play. Once you have your answer, you're going to move the decimal back so that there's still the same number of digits behind the decimal place. So looking at this 56, there is technically where my decimal point would be, I'm going to move it so that I have 4 digits behind the decimal place. So my final answer would be this 0.0056 because I still have 4 digits behind the decimal. Back to our notes and back to looking at negative and positives of multiplying decimals. This first example, I have a -8 times 0.74 or 74 hundredths. I see a negative times a positive, so I know that's going to be a negative answer. And when I go to do the actual multiplication, I'm going to set it up as 74 times 8. 8 times 4 gives me 32. 8 times 7 gives me 56, plus that 3 added on top would be 59. And I need to go back to my original problem and see how many digits I need behind the decimal. There's only 2 here, so I only need to move it 2 over. And I also need to remember that it's going to be negative because I have a negative times a positive. So my final answer would be a negative 5.92. Over here, I have a negative 3.1 times a negative 5.8. A negative times a negative is going to be positive. Keep that in mind for my final answer. But set up the multiplication without those decimals. So 58 times 31. I'm going to look at the 1 first. So 1 times 8 is 8. 1 times 5 would be 5. Moving over a place now, I have 3 times 8, which is 24. And 3 times 5, which is 15, plus that 2. Remember, for these, you add up your columns. So I'm left with 1, 7, 9, 8. Count how many digits I need to move it, which is 2. I have a positive answer from my sign rules, so a final of 17.98. Many of you have been referencing KFC from 6th grade. When dividing with fractions, what KFC helps you to remember is that you keep the first fraction as it is. So looking at this example of 3/4 divided by 2/3, I need to keep that 3/4. I flip the second fraction. The more mathematical way to say that would be to get the reciprocal of the second fraction. So instead of 2/3, I'm going to write 3/2. And then I change it to multiplication. Now, many of you might have been tempted to try to simplify this original problem, but we can't simplify until it's rewritten as multiplication. So looking at the problem now, I see that in reality, I can't actually simplify anything. So don't fall into the trap of trying to simplify here. Now that it's multiplication and I can't simplify, I'm going to multiply straight across. 3 times 3 being 9. 4 times 2 being 8. And again, if you prefer, you can take that a step further and write it as a mixed number of 1 and 1/8. Back to our notes, looking at a negative example of dividing fractions. I have a negative divided by a positive, a -4/5 divided by positive 2/3. Again, in the back of my head, I'm thinking my answer, I want to make sure that it's negative according to my sign rules. I'm going to flip and get it all set up before I can look to simplify. So a -4/5, this time times the reciprocal of 2/3, so 3/2. And looking here, if you wanted to, you could actually simplify the 2 and the 4. 2 goes into 4 2 times. When I go to multiply across now, I have a -2 times 3, which is -6, and a 5 times 1, which is 5. Again, if you like, you can turn that into a mixed number of -1 and 1/5. Dividing decimals is very different than multiplying with decimals. When you're dividing decimals, the key is the number you're dividing by, called the divisor, needs to be treated as a whole number. So to do that, you look at the decimal point and you move it however many spaces so that it becomes a whole number. So with this 0.2, that was my divisor, I need to move that decimal only one spot to the right to get it to become 2. I'm not allowed to do it to one side without having to do it to the other side. So with this 15, I also need to move its decimal point 1 over, having it become 150. Mathematically, these two problems have the same value. 15 divided by 0.2 is the same as 150 divided by 2. So when I go to solve, I'm only thinking of 150 divided by 2. 2 goes into 15 7 times, with 1 left over, and 2 goes into 10 5 times, with none left over. So I know that my final answer here is 75. Back to our notes, a negative version of dividing decimals. Again, if I'm looking at my sign rules first, I see a negative divided by a positive, keeping in mind that that's going to be a negative answer. Then I need to look at my divisor. My divisor here is 0.6. I need to move that decimal only 1 over to the right, and I'm also going to do that to my other number. So I'm looking at negative 138 divided by 6. Setting up my long division, 6 on the outside, 138 on the inside. 6 goes into 13 twice, with 1 left over. And 6 goes into 18 3 times, with none left over. So I have 23. And then again, needing to remember that it would be negative because I originally started with a negative divided by a positive.